Hey guys, so in this video, I'll show you all the different types of numbers that you need in order to really understand the fundamentals of algebra. So let's go through them. There's a bunch of different types of numbers that we have listed here. And first, let's talk about the natural numbers. So the natural numbers right here, they are numbers like 1, 2, 3, 4, etc. They're just the counting numbers. Whatever numbers you use to count anything. 1, 2, 3, 4, 100, 200. These are natural numbers. Whole numbers are all the natural numbers plus 0. So all the whole numbers are 0, and then 1, 2, 3, 4, etc. All the whole numbers. Now, integers are all the whole numbers plus all the negative natural numbers. So we can start like this: -3, -2, -1, 0, 1, 2, 3, and so on from the other side too. So -50 is an integer, 50 is an integer, and all of these numbers are integers. Now, rational numbers are all of the numbers in between. So, for example, what's between 1 and 2? What's exactly halfway between them? There's 1.5. What's between 0 and 1? That's a half, which can also be written as 0.5. These are rational numbers. And also, all these integers are also rational numbers. 2 is a rational number. 3 is a rational number. Rational numbers are basically any number that could be written as a fraction. So, for example, 3 is a rational number because it can be written as 3 over 1. 0.5 is a rational number because it can be written as 2 over 1. Or, sorry, 1 over 2. 1 over 2. So if a number can be written as a fraction with a whole number numerator and denominator, then it's a rational number. And now on the other hand, we have irrational numbers. So the most famous irrational number is pi. So pi, it's equal to 3.1415, etc. And the reason it's irrational is because, one, there's an infinite amount of digits of pi, right? But two, it's because pi can't be written as a fraction. There's no fraction you can write that'll give you every digit of pi. And that's the key there. Another one is square root of 2. So imperfect squares, such as the square root of 2, square root of 3, these are also irrational. Because one, they can't be written as any fraction. And two, they go on forever. Now, there are actually some rational numbers that go on forever, but they're still rational. For example, if we just get rid of some of these, we have 1/3. 1 divided by 3, if you put it in your calculator, it's 0.3333 forever. This goes on forever too, but it's still a rational number. It's not irrational because it can be written as a fraction. You can express this these infinite digits right here by writing 1 over 3. And that's the key right there. If it can be written as a fraction, it's rational. And if it can't, it's irrational. And often the irrational numbers go on forever. So let's scroll down a little bit. Just get rid of that. And basically all of these numbers that I described here, every number there is a real number. So a real number is every number that I've described here. It's all the irrational numbers, all the rational numbers, integers, whole numbers, natural numbers. So these are all real numbers. Everything here. So why are we calling them real numbers? Well, because there are some numbers that are not real. imaginary numbers. And we'll talk about the properties of imaginary numbers more in a later video. But the important thing to know with imaginary numbers is they all revolve around the idea that you can't take the square root of a negative number, square root of -1, for example. And to see why this works, whenever you take a square of something, whenever you're looking at the other side of it, 3 squared, that's 3 times 3, which is 9. Therefore, the square root of 9 is 3. And to be more precise, it's plus minus 3, because 3 times 3 is 9, but also -3 times -3 is also 9, positive 9, because a negative times a negative will give you a positive. Now, the important thing here is, what's the square root of -9? What if I ask you that? Well, you can't find it within all the real numbers, because it doesn't matter what two numbers you add, or what two numbers you multiply, rather. It'll never give you -9. It doesn't matter if you add 3 times 3, -3 times -3. They both still give you positive 9. There's no way to get -9 in the real number area. That's why we use imaginary numbers, and we express this one, the square root of -1, using the letter I. And we'll talk about the properties of imaginary numbers in a later video. But really, these are all the different types of numbers that you need to really understand the fundamentals of algebra.